of our Piecewise lesson. We're going to focus on graphing and writing equations for piecewise functions. On your piece of paper here, looking at example number 1, it says write the equation for each piecewise function in function notation. Be sure to indicate the domain for each piece. Well, what is function notation, first of all? Function notation is when we're going to write the phrase f of x. That's how you say it. And now I'm going to show you what that looks like. Just one moment here. Get this all plugged in. So when we talked about functions, domains, and range earlier this year, function notation, so when we write an equation, so far we've always just wrote y equals. Okay, unless it was a vertical line, we had x equals. But we might say y equals 3x plus 2. Y equals negative x plus 5. Y equals 2x minus 3. So instead of having to write y equals over and over again, we're going to take that part off, okay? And we're going to say f of x. So you write f, open parentheses, x. F of x equals, and what you're going to do is draw a bracket around there, okay? So instead of having y equals for all 3 separate equations, we're going to say f of x equals, and we'll draw the bracket, and say these are my equations that all go together. And so that bracket is showing that I want all of these equations together, okay? And then off to the side, I like to use inequality notation when I'm writing equations in function notation. So then let's say I wanted this to range from negative 2 to 0. And then I'm going to start at 0 and go to 1. And this is always going to be everything greater than or equal to 1. Okay, so then, bless you. Sometimes if you see this like on a worksheet, it might have like a semicolon there. There could be commas, but you would just, this is what function notation looks like. Okay, so let's go ahead and look at the first example. And so when we write, this is a piecewise function, because there are multiple pieces on one graph, okay? So if there's 3 pieces, we need 3 equations. I work left to right. So I'm going to write an equation for the graph for this to the left, and then that horizontal chunk, and then the graph on the right. So if you were to extend this graph over here, I personally always start with the starting point. Where would it touch the y-axis? Where would that blue line extend up to? 2. And what is the slope of that line? 1. Up 1 over 1. Up 1 over 1. Okay? And so our first equation then is that, and I write my starting point first. You are fine to write x plus 2, but I say, okay, where am I starting? And then I write my slope times x. Either way is fine. You can either have 2 plus x, and so off to the side, we're going to write f of x equals, and draw yourself a fairly large bracket, because we're trying to write 3 equations here. And I've already spilled the beans here. I have the answer up there for my inequality. So first of all, I notice that I have 2 closed circles. And so both of these signs need to be less than or equal to. And I'm trying to say my domain, what numbers I can plug in, is ranging from negative 4 to negative 1. Is everyone okay with that domain listed there? Negative 4 to negative 1. So then we're going to jump down to the next equation, and that's a horizontal line. And those are always y equals, and again, y is my f of x. And so where am I the whole time? 1. What is my domain? It's going from where? -1 to, and I'm crossing through. So the 1 in my equation right here is for the horizontal line. My domain, -1 to 1, is this area here, the width of it. Sometimes you can lay your ruler on your graph and see where that third equation would touch the y-axis. But what would be another strategy if you didn't have a straight edge with you? Count the slope and work backwards. Thank you. So I'm seeing perfect corner here where my cursor is and a perfect corner here. So that's down 2 over 1, down 2 over 1. What's my y-intercept? -1. So again, I write -1 plus 2x, okay, where you all, if you write your slope first, right here in green, you would have 2x minus 1, okay? And that domain then is being listed. What is my width of that line? It's going from -1 to 4. Okay, so let's go on to the next example here, and I'm going to let you try to write those equations, okay? Remember to write f of x, draw your big bracket. Looking at your papers here, I noticed that I didn't say, or I'm not seeing equal signs. If you look back at example A, squeeze in an equal sign in between your, yeah, I had it there too. Okay. So it's f of x equals, and then your bracket. Many of you just had f of x and then the bracket. Okay. Let you work on number 2 just about a minute longer. All right, so let's go ahead and check how we did on number 2. So first of all, our slope is 1 over 1, and if we continued that, we would have touched the y-axis at 2. So starting point plus 1x is my slope. My domain is ranging from -4 to 1, Notice though at the end of this first line I have an open circle. Can you check and make sure that you have a less than sign here that's not underlined? So that open circle here means that I'm going to be just less than. Second equation, again, is that horizontal line. This time that horizontal line is at 1, 2, 3. So it's just F, I just write a 3 there. That would be the same as y equals 3. And it is stretching from -1 to 1. However, it looks like I need, that's solid there, so this needs to be underlined. And then the slope of my green line this time again is 2. And if I go down 2 over 1, down 2 over 1, my starting point is at +1 on the y-axis. And this time it's ranging from -1 to 4. And the third example here, again, I have that horizontal piece I'm going to start with this time. So f of x equals is where we're headed here. Okay, so we're starting at 7. And that domain is ranging from -4 to -1. Again, the open circle here needs to be designated in your domain with the less than sign and not less than or equal to. My y-intercept, I don't have to find it on the middle section here. It is actually touching the y-axis at 5. My slope this time is negative though. Can you make sure that you have -x minus 5, or what I have as 5 minus 1x? And that range, or that, excuse me, that domain is going from -1 to 1. Both of them are closed circles. And the third equation here, again, has a negative slope. Looks like it is a 2, up 2 over 1 though still. And if I go up 2 over 1, I would also have the same y-intercept. That green line, or my third section there, would extend up and also start at 5. And the slope is negative. So you're either going to have 5 minus 2x or -2x plus 5. This time, both of those are open circles, and so both of these are just less than signs without the equal to part. Show me what you think about writing the equations for the line. So 1, you, and 5 is your great at writing the equations from a graph. Okay, so two things we're always identifying: the starting point and the slope. So some of us are more confident than others, but you're going to have plenty of practice with that this week. So going on to example number 2, if you want to flip your packet if you haven't yet, we're going to have the opportunity to practice graphing. So we're going to do the exact opposite of what we were just doing. And so notice here is function notation. And so sometimes on the computer, they have the bracket on the left and the right side. And it's just different formatting, okay? So notice on number 1, we have the opportunity to say that this equation is going to be from 1 and below, or just less than 1, and the second equation is going to go from 1, including 1, forever the other way. And so we won't have segments, but we're going to have rays that we draw on our graph. We're going to have 2 arrows once we get done with this graph. So let's go ahead and start with 3x plus 2. So I go ahead and plot my starting point at 2. I'm starting at 2. Okay, and my slope is up 3 over 1. 1, 2, 3, 1, 1, 2. And so positive slope, I can go down and to the left, down and to the left. Okay, so all of these red dots on my screen right now are for this first equation. But where do I want it to exist from? Okay, so before I draw my line, I might want to think about my domain. I want to only plug in numbers less than positive 1. So actually all of these dots then would exist, right? But if I kept going up and over, then not. So I want to have an open circle here. And I want to extend this down through the trend of what's there. Let's see if I can use a straight edge here. Well, that's super thick. Nope. There's the settings for it. There we go. That's better. Okay, so we have an open circle, and then we're going to have an arrow somewhere. So you could have maybe even stopped here. I would have been fine with that if you would have stopped your graph there. But we need an arrow showing that that segment is going to ray, okay, an end point with an arrow. It's going to extend forever this direction. Second equation is starting at, see, I'll grab purple here for this one. Second equation is starting at -1 and has a -2 over 1 slope. So I'm going to start at -1 on the y-axis. Well, I grabbed purple. Let's see if I can try that again. There it goes. Starting at -1, my slope is -2, so down and to the right, down to the right, down to the right. And so this time I want a solid circle here. And if I wanted up and I plotted more points there, those don't exist though with the domain. Okay, so all the purple dots right now, you work for this equation. Okay, but the domain says I need to start here. Nope, not right there. Where does it say I need to start? I need to start at 1. I need in a closed circle here. Okay, and I'm going to extend this direction and have an arrow. Okay, so even though I needed that starting point to get my slope started, it doesn't then contribute to my actual graph. Any questions over number 1? If it is a function, you should never have 2 solid dots. Remember the definition of function is that every input has 1 output. If I would have had a solid dot here at the top of the red, if I would have had a solid dot here and here, then it wouldn't be a function anymore, because this value of 1, I wouldn't know if I needed to plug it into this equation to get the answer, or if I should plug it into this equation to get the answer. Looking back at those other graphs though, see how when they weren't touching it was open, solid, solid, open? It's okay for them to both touch at the same place and be solid, because the lines are overlapping and you're going to get the same answer with either equation. But as soon as the pieces of a piecewise function aren't touching anymore, you're going to notice it should be opposite signs. They could both be open, but they both can't be closed right there, just so you know. Okay. Let's see here. We have 3 to graph. Let's do one more together and then you can try the next one. Okay, so on B, we're starting at 1 for my slope, or excuse me, 1 for my starting point. My slope is negative 2 over 1 again. And where does that exist from? X less than negative 2. So I need to find negative 2 on the x-axis right here. And I'm going to have a solid circle. And I'm only going to use that portion. Right? So then if you wanted, you could erase the rest of those dots. So that's the only piece that exists for here. Second equation, when it's just a 3, what type of line is that going to be? Horizontal. So I'm going to go up to 3, 1, 2, 3, and put a dot. And I know that I want to exist from where? I want this horizontal line to go from negative 2 to positive 3. And I need to decide what my circles should be, my endpoints. On the left side, should it be open or closed? Open. And on the right side, closed. And the third equation here is negative 3 is my slope and 5 is my starting point. Grab a different color here. I'm going to start at 5. 1, 2, 3, 4, 5. Slope is negative, down 3 over 1, right? You always use your rise and run. Down 3 over 1. 3 over 1. Might go again. 1, 2, 3, 1. And I asked myself, what do I want my domain to be? I want it to be 3 or bigger. So I find 3 on my x-axis. 1, 2, 3. And it's going to start here as a open circle and extend through. I'm going to redraw that open circle. It's a little obnoxious. Open circle, point, arrow, because it's extending forever. Let's take 3 minutes and see where we can get on example C and D. 3 minutes. Let me know what questions you have. All right, let's go ahead and check and see how we did here on example C. So we're starting at +1 for our y-intercept, and we have a -2/3 slope. We want it to range from -6 to 3. So I started at 1, I went up 2/3, up 2/3, back to 1, down 2/3. That ended up being a closed circle on the left with the open circle on the right. Now, what I have written up here in green and blue, that's what's happening here. Remember that y equals x? That's what this is when it says f of x equals x. The number in front of x when it's not there is a slope of 1. The number when you don't have a starting point is 0. So please make sure you don't have a horizontal line here of any kind, but you would have started at 0 and had a slope of 1/1 all the way up, but I only wanted to start at 3. So from 3 with a closed circle, we're extending up and to the right with an arrow at the edge of our graph. Any questions there? On D, we do have a starting point of 2 when so the starting point is listed first, and then our slope, so 1/2 slope, starting at 1, up and to the right, down and to the left. I need this to be an open circle. I have a dot on top of an open circle. I'll go ahead and draw that again. So open circle there. A domain is extending from -4 to 2. And then we have the second equation is starting at the y-intercept of 5. And it doesn't, though, start until an open circle at 2 extending to the left. What questions can I answer about graphing? Give me a thumbs up if you think graphing is easier than writing the equation. Give me a thumbs down if you would rather write the equation from the graph. Which one do you think is easier? Okay. Thank you. It's different every year. Sometimes I have students I would much rather have the equation and produce the graph. Some students just don't like the fact that they have to graph it and then go back and decide where do I really want it to exist from. So some students like the equation part better because they think it's easier just to write the equations. So, if there are no questions over graphing, we're going to go to the third and final part. Well, not quite the final part of our notes here. Third part is being able to evaluate using the function. So looking at example 3, you have a function given. We have 3 equations, 3 areas where the domain exists from. And what's happening here on A is I'm asking you to find the answer. So there's 2 ways to do this. The second example that you see, which you'd have to flip the page over, I give you the picture of the graph to find the answer. This time it's just giving you the equation. So you ask yourself, where does 6 belong in the function? Like which domain does it fit in? Does it fit in the first one? Is 6 less than -2? Is 6 between -2 and 3? Is 6 bigger than 3? So that's how you know which equation to use. You take this number, it's saying f of 6. It's wanting you to take 6 and plug it in, okay? And the one step that you have to realize is which equation to use. We're going to use the third one. So you're on your paper, you're going to write -3 times 6 plus 5. That would be the work of you showing me which equation you plugged it into, okay? And you can maybe do this in your head, just type it straight into your calculator. What is -3 times 6 plus 5? -13, because you're going to get -18 plus 5, and that is -13. So the solution of f of 6 is -13. Okay. Where does -5 fit in? Is -5 smaller than -2? Is -5 smaller than -2? Yes. Think about the number line and where that would hit, right? So this time I'm going to use the top equation. So I would say -2 times, what you want to plug in is -5 plus 1. And -2 times -5 is 10 plus 1. Okay. Third example, f of 3. Okay, is 3 smaller than -2? No. Is 3 in between -2 and 3? Yes. So this is up to 3. This one is bigger than 3. So this time we're going to use the middle equation. What's the answer? 2. Okay. So what that means is, guys and gals, if I had a graph and I graphed this says f of x equals 2. From -2 to 3, you just have a horizontal line. So if I ask you what is f of -1, you tell me 2. F of 0 is 2. F of 1, 2. F of 2, F of 3. All that whole chunk, all of these x's that you plug in that chunk, all have an answer of 2, no matter what. Okay? F of -2. And this is a tricky one, right? Where does it fit? Does it fit in the top equation or the middle? The top. Because with this underline, this equal to, this is where it fits. So I'm going to do -2 times -2 plus 1. And that would be 4 plus 1, which is 5. Okay? So that is simplifying or solving using an equation. And then example 3b, or example 4, I guess is what I called it. Let's look at how to use it from a graph. So if I say f of -1, you're going to find the values on the x-axis. Right? So f of -1, I'm wanting to plug in -1, and then I look, where does the graph exist? What does it say the answer is? I go up to the red line, and what is that? What's its ordered pair partner? Go ahead. 5. Okay? So if I plug in -1 on that graph, I get 5. Okay? So -1, 5. What about if I plugged in a 2 on this graph? Over to 2, what's its output? What's its y partner? 1. I want you to try C and D. And the ordered pair isn't the answer, guys and gals. It is this. Like, This is the answer. I'm just trying to show you with the ordered pair. Like I'm going here on the x-axis and then I go up, and where does the graph exist? Where does -2 exist at? At 5, right? Because this open circle doesn't count. Good. What about -3? Over to -3. 1, 2, 3. -1. How do you feel about that? Finding the answer on the graph. 1 is like, 5 is I get it. Okay. So when you're working today, if you aren't very confident with that, let me know. So example 5, this is going back to what we did for the activity after our last quiz, where it's called linear pieces. We have some time here before lunch. I'd like you to read that word problem, and I'd like you to try to write the equations. And list out the domains, okay? And we should be able to do this without a graph, okay? Sometimes the graph is nice to visually see like where that's existing from, but remember, you can just use like point slope form to find and work backwards to find that starting point when needed, okay? Go ahead and take 2 minutes here. So we're trying to write an equation for each interval. Okay, so I started with So write down either negative 15x plus 135 or 135 minus 15x. Okay, and so they don't tell you how much they have at this next portion, but they don't use any for the next 6 days, right? So you need to do a little calculation to see if I used 15 gallons for 4 days, how much would I have left for that horizontal chunk? Looking at is that 75 needs to be different because, like, where would I have been on the y-axis? That's not the actual starting point. That's just the starting point for that segment. Okay, so I like your top one here. Can you tell me how you got 11? So what that 11 should be is how much water I have on day 5. Okay. Yep. Okay, so for the sake of time here, we're going to go ahead and talk about how we could approach this problem. So starting with the fact, for most of us, we wrote f of x equals, that's awesome. Okay, what does it equal? Okay, we have 3 segments here. The first segment is that we had 135 gallons and we were using 15 per day. So you either have negative 15x plus 135 or 135 minus 15x. And that happened for 4 days. So that happens between day 0 and day 4. Okay? Day 5 through 11 is where we're at next. On a word problem, sometimes these, should I actually underline these, needs to kind of come at the end and kind of talk through that. So right now I'm just going to leave them as less than signs, and we'll come back and make them equal to if we need to. Okay? So how much water do I have then on day 5? Can someone share how they calculated how much they had? Emily, will you share what you did?
I took 15 times 4 and got 60, and then I subtracted it from 135 to get 75.
Okay, awesome. So just kind of that concrete way of saying, okay, this is, I had 135 over 4 days. I used that 15, so I know that I have 75. And that's all I need to put there is because I have, remember what this would visually look like. It's just that horizontal piece going across the graph. Okay. Then I have the idea that I'm using 10 gallons per day. Okay. But what should our starting point be? I'm using 10 gallons on day 12 through day 14. Does anyone have a starting point there? So it's not going to be 75, right? But it's this idea that I had a graph that was decreasing, and then it was horizontal, and then it started decreasing again. If I extended that up, I want to know where I was, right? So this is where I personally chose to use point slope form, okay? And I said, well, on day 12, if I'm now using 10 per day, 75 minus 10 is 65. And so I said 65. Well, actually, I didn't use point slope. I just used y equals mx plus b. I did 65 minus, or 65 equals the fact that I'm using 10 per day and 12. So y equals mx plus b. And negative 10 times 12 is a negative 120. And you can add that 120 over to figure out where you would have been up here. And that would have been 185 as that starting point. If you wanted to use that point slope, again, you could have done y minus 65 equals negative 10 times x minus 12 distributed and then added the 65 over, it would have been the same thing. Okay, so 185 was that starting point that we needed to calculate. All right, so at this time, we're going to pause our notes.